All right, 2.1, relations and functions. So we're going to talk about one-to-one function, onto function, discrete relation, continuous relation, vertical line test. Y'all should all remember that one at least, do you? Vertical line test. Good. Independent variable, dependent variable, and function notation. Okay? All right. So write these down because these explain what one-to-one function is, onto function, and then both. All right, so one-to-one function, each element of the domain. What do you think the domain is, x or y? X, good. So each element of the domain pairs to exactly one unique element of the range. So x goes with y, right? But I can't have two different x's going to the same y. That's what it's saying. Each of them goes to a unique y. Okay? Onto function, each element of the range corresponds to an element of the domain. So I can have two different x values going to the same y. That's okay, as long as they correspond together. All right, the range is my y. And then both one-to-one and onto, each element of the domain is paired to exactly one element of the range, and each element of the range corresponds to a unique element of the domain. That means I have an x value with a y value, and then I have a different x value with a different y value. Make sense? All right, for one-to-one, you have x values with unique y values, right? None of them are going to the same y value, okay? For onto, you have y values going to x values, but they can go to the same x value. So for both one-to-one and onto, if you have an x, it has to go to a y, but then you have to have a different x going to a different y. Okay, so let's just practice it. State the domain and range of the relation. Then determine whether the relation is a function. If it is a function, determine if it is one-to-one, onto, both, or neither. So I'm going to let y'all draw that real fast. All right, so we already talked about what domain was. What I say the domain is? The x's, right? So domain, it's a set, and what's my smallest x? No. -4, good. What's my next smallest x? -3. Then 0. Then good. What's my range? Here we go. Range. So -2. -2. I don't see a -1 anywhere. 1. Now, how come I didn't write -2 twice? I see two y values of -2. You only have to write it once, right? All right. Is this one-to-one, onto, both, or neither? You think neither? Okay, I'm going to pause this so we can discuss it. Okay, so I'm going to put all my x's. Then I'm going to put all my y's. Ooh, I don't want to draw the line between it. Okay, my x's are -4, -3, 0, 1, and 3, right? Then my y's are -2, 1, 2, and 3. What does -4 go with? Oops, -2, not -2, -3, 0. Thank you, -2, 1, 3. So look, for one-to-one, your x values have to go to different y values, right? For onto, my y values have to go to different x values, right? So it's onto. Because 0, -2. That's a point. What? Oh. What? What? It's the Little Dipper. Thank you. Good. Okay. Does everybody understand this? So if your x's go to different y's, it's 1 to 1. If your x's go to the same y, then it's onto, right? Makes sense? Okay. So try this one. Oh, this one's different, actually. It's a lot easier. State the domain and range of the relation shown in the graph, and is the relation a function? So, now's a good time for me to tell you what a function is. If you have the same x value with different y values, it's not a function. Okay? One more time. If you have, do you want a real life example? If you have 0.2, -6, 3, 2, and 2, -5, did you hear I said 2 twice with the x's? It's not a function. So when your x value has 2 of the same numbers, it's not a function. If your y value is repeated, it doesn't matter because it has a different x, okay? But if your x is repeated, it's not a function, okay? Now, is that the same number if x is -2 or x is +2? No. Now, you can still tell me the domain and range, but then you just write not a function or is a function. Okay, what's my domain? Okay, and my range? That shouldn't take long at all, should it? No. And is this a function? Yes. Because none of my x values are being paired. None of my x values are being doubled, right? Paired with different y values. They're all just once, right? Okay. We don't have to talk about if it's 1 to 1 or onto. I just want you to tell me if it's a function or not. I don't know. Is it? It's 1 to 1. Is it onto? Yes. So it's both. It's 1 to 1. It's onto. So it's both. How is it onto? Because every y value is paired with exactly one x value. And every x value is paired with exactly one y value. Do you remember the example on the last example? All of them are just being paired with one thing, right? So are all these points just being paired with one other y? Yeah, none of them are being repeated, are they? Okay. All right, vertical line test. You guys in Algebra 1 probably would have used your pencil, okay? Yes, you remember that now. Good. If you take your pencil and lay it down on your paper and drag it from left to right, and it doesn't touch 2 points on the graph at the same time, then it's a function, right? But if you take your pencil or your finger or whatever and drag it across and it touches 2 points, it's not a function, okay? So if no vertical line intersects the graph in more than 1 point, then the graph represents a function. If a vertical line intersects the graph in 2 or more points, the graph does not represent a function. That's what I was trying to tell you on the last one. Do you see this right here? I have the same x value, right? What's my x right here? 1, but when x is 1, it's -2. And when x is 1, it's about 1.3 or something. See how that x value is being paired with 2 different y's? It's not a function. Page 62 at the bottom if you're not finished. So, the table shows the average fuel efficiency in miles per gallon for SUVs for several years. Graph its information and determine whether it represents a function. Is this relation discrete or continuous? Here's the deal. With discrete, you have unique points on a graph. You should be listening to me. For continuous, it's a line. It means it goes on forever, right? Continuous, go on forever. Discrete, unique points. Okay? Okay, copy this down, then we'll do it. Okay, which ones are my X's? The years. So that's what's going to go here, right? Years. Or year. So I have 01, 02, 03, 04, 05, 06, and 07. Now, do I need to go from 1 all the way to 20 point something? No, why don't I make a break in the graph? Yeah, can I do that? Yes, I can. I can make a break in that graph, can't I? Yes, and I should start with 20.5. So we're going to go by 0.5s. Okay, 20.5. So the next one would be 21, and then the next one's going to be 21.5, and the next one's going to be 22. Do I need anything above 22? Yes. 22.5. Now am I good? Okay. You guys want to do it, so put a 23. I don't care. We didn't necessarily need it, did we? No. It's fine, though. I don't care. It's a 3. It's kind of hard to write small with this. All right. 01. What does 01 go with? 20.8. So it's going to be about right here, right? A little bit lower, probably. OCD, math. Okay. 02 goes with 20.6, so it's going to be lower than that. 03, again, right? 04, 20.9, so it's going to be a little bit higher. 05, 05, 21.6, so it's going to be above this line right here. 06, 22.3 is going to be up here. Not quite to that. Is that quite to it? Yeah, I need to bring it down a little bit. And the last one, 22.6, is the highest, right? Now, is this discrete or continuous? Discrete. Because as she was saying, did I have to pick my pencil up? Yeah, I did, didn't I? Okay, it's not a linear function. Now let me ask you, is this one-to-one, onto, or both? It's what? It's one-to-one, right? Each x is paired with a different y. But do you see how this y value right here? It's right here, right? I have two y values that are the same. So it can't be onto, so it's only one-to-one. Okay, so here's my trick for you. If you put your pencil down, up and down, and go across that way with your pencil up and down, and it doesn't hit 2 points, it's one-to-one. If you put your pencil down, though, with your pencil going left to right, and you drag it up your paper and it doesn't repeat, it's onto. Do you see if I had my pencil laid down like this and started going up, do you see that it's hitting both of these at the same time? So it can't be onto, can it? So tell me then, which of those is a function? A one-to-one or an onto? One-to-one. With the vertical line test, right? You do a horizontal line test, that'll tell you if it's onto or not. Okay? All right. So you guys try this one. Let me move that so y'all can see. You should have drawn a graph, right? What are my x values? The age in months, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Just because I put it on that line doesn't mean I have to include it. No, I don't. Okay, should I create a break? Yes. Right? So what's my first number going to be? Why don't we just start with 12, then do 14? Good. Okay, some of you went by 5s. It's a personal choice. It takes forever, doesn't it? And all I needed was up to 26, so I can stop. What goes with 1? So it's going to be here, or maybe a little below that, but that's okay. 2 goes with 16. 3 I don't have, so skip it. 4. 6. See, I'm just skipping those exercises that I don't need, right? 7, don't need. 8, don't need. 9. And 12. Okay. Discrete or continuous? Discrete. Does it represent a function? Yeah, every x value is mapped with a different y value, right? So is it 1-to-1? If I do the vertical test, if I do the horizontal test, it's both. And they didn't tell us to do that, but it's good just to practice it because you're going to have to do it in your homework, okay? It is discrete. It's not continuous because it's unique points, right? I had to pick up my pencil.
So if they're onto and
Okay. Okay. Y'all, start looking at this one and graph it. You've done this with quadratics. You should be able to do it with this one, right? Y equals 3x minus 1. You should just pick some what? Some x values, right? Then you plug it in for your y equals. Let me tell you, your x is called independent because you're choosing it, right? It doesn't rely on something else. So what do you think your y value is going to be called? Dependent. It depends on what your x is, right? That determines what your y is going to be. So you guys pick some points and graph it. F of x is function notation, and that's in a few of them after this. It's the same thing though, right? All right. How can a function be neither? If you have x values repeating and y values repeating, it's neither because you have, the same x being paired with 2 different y's. Then you have the same y being paired with 2 different x's. So it's neither. All right, I'm going to pick -2, -1, 0, 1, 2 because that's just easy for me, okay? Plug it in. -2 times 3 is -6. -6 minus 1, -7. 3 times -1, -3 minus 1, -4. I don't even have to do any work because that's my y-intercept, isn't it? Yeah, 0. When you plug it in, that's your y-intercept. When I plug 1 in, I get 3 minus 1, which is 2. 2 in, 6 minus 1, which is 5. We picked the same numbers. Good. So -2, -7. 1, 2, 3, 4, 5, 6, 7. -1 goes with -4. 1, 2, 3, 4. 0 goes with -1. That's my y-intercept. 1 goes with 2. And 2 goes with 5. Now, that's a linear function, right? Do I have a slope? Yes. What's my slope, y'all? Up 3 over 1. Your slope is found right there. Mx plus b. Remember that from Algebra 1? M is your slope, b is your y-intercept. Okay. So don't make fun. My line's probably going to be terribly crooked. So, discrete or continuous? Continuous. Could you pick different points than me? Yes. It's still going to be a line though, right? It's linear. Okay, you guys do that one.